Okay, so the purpose of this tutorial is just to run through the flow control components and explain briefly what each one does. Okay, so the first one that we have here is the auto to type component. So you may know that there are three different types of data that are transmitted on the canvas. We've got single figure, which is yellow, octave band, which is blue, and third octave, which is green. And what the auto to type component does is it looks at what the input type is and then sends it to the corresponding output node. This may be useful if, for example, you had a container where you wanted to treat the input differently depending on whether it was a single figure or octave band input. So to illustrate this, I've got I've got a single figure input here and an octave band input, and I've got single figure read and octave band read here. So if I connect up the single figure, for example, I can connect up the reads to both the corresponding nodes, and if I type in 10 in the single figure, for example, you'll see that the 10 is sent to the single figure output. Okay, whereas if I disconnect this now and then plug in the octave band, I can put some values in there, and you'll see now these are sent to the octave band and the single figure is blank. Okay, so that's basically what the auto to type does. Let's get rid of that. So the next ones, we've got the bridge in and bridge out. What these components do is allow you to send data from somewhere to somewhere else on the canvas. So for example, if I just get rid of these. So we've got this single figure here with 10 on it. Let's just call it input 1. Okay, so now if we plug that into this bridge in, we'll see that input 1 appears here on the bridge out component, so we can connect that up, and we've got 10 there, and anytime we change anything on this, it'll be sent through the bridge to the output. So that just allows you to send data to other places in your assessment. Okay, so the next one that we've got then is a conditional flow control component. So what this will do is it will look at the inputs to it and make an assessment of how they relate to the condition that's been specified, and then send a corresponding output. So it's similar to an if then else type sort of programming kind of loop. So if I take some single figure inputs here, for example, and a single figure out, and just connect these up. So if I was to say, I put 1 in here, 2 in here, 3 in here, and 4 in here. So if I set the condition to be less than, for example, what it's going to do now is look at this, the first input, and say if the first input is less than the second input, then send through the third input here. If it's not, then send through the fourth input. So as we can see here, 1 is less than 2, so therefore 3 is being sent out. If I was to change this to 3, for example, now 4 is being sent through because 3 is greater than 2, so the condition is false. If I was to set it to equal, for example, and I put both input 1 and input 2 to 2, it will say is 2 equal to 2? Yes it is, so 3 is being sent through. And if I changed it to a different value, it's no longer equal, so 4 is being sent through. So that's what the condition component does. The container link in and link outs are used to send data into and out from a container. They'll be looked at in the containers tutorial. The octave band combiners and splitters that you can see down here basically split up a data stream into individual single figures, or combine it into a kind of a multi-band data stream. So if we were to, for example, take a let's take an octave band read. I'm sorry, an octave band value here, and plug that in. and put in 1, 2, 3, 4, 5, 6, 7, 8. And then if we take a single figure output and just plug some of these in, so you can see now it's picking up the individual bands that are coming from that multi-band stream. So what we could also do is if we have an octave band combiner, that basically does the opposite and will take the values that we plug into it in single figures and it will pass them through into a band stream, for example. So this might allow you to, say you wanted to undertake a specific correction on each individual band, then you could do that and then combine them back or something like that. And then the other components that we have here, let me just clear up the canvas a little bit. So the next one that we can look at here, we've got a single figure to band. What this one does is it will take the input as a single figure and replicate that across all octave bands or third octave bands, depending on what you plug into it. So we can see there that one has been put across all octave bands. So if you had a single figure that you wanted to be able to use across all octave bands, that would be the component that you would use. And then the final component in the flow control section is a switch, which basically allows you to switch between the different inputs that are connected to it and take the output that you specify. So if I get a single figure output and plug these 4 inputs that we had into this switch, it uses the label of the module to identify it. So let's just call this input 1, input 2, input 3, and input 4. Okay, we can now see on the switch we've got input 1, 2, 3 and 4 there. So if we plug this into our single figure read, depending on which one we select is the one that it will show us. Okay, so that covers pretty much all of the flow control components. Like I said, the container link in and container link out components are used specifically with containers, so they'll be discussed in the container tutorial.